Hi friends, welcome to our channel. So here we are going to look at this problem, clone binary tree with random pointer. So as in our previous several videos, so here the idea would be the following. So data structure first would be dictionary or hash map. So this is the one thing. And because this is a tree or graph, so we need to do traversals. So for traversals, basically for traversal coding, there are two formats. So one is iterative, and the other is recursive, right? So here, actually, because tree is a very important data structure itself, involved in this problem, we are going to present both iterative and iterative, iterative and recursive, right? So first, I'm going to write a short solution. So in other words, I'm going to use recursion first, and then we also write a iterative format to digest the detail, right? First, let's look at this one. So basically, we are given a binary tree, and each tree they have four fields for tree node: value and left and right. So this is very standard, right? It also has a random field. It's going to point to another node. So here, notice that this left, right, and random. From this definition, we should regard them as node instance in general, right? So here, let's look at the constraints. So the number of nodes in the tree is in the range given by the closed interval 0 and 1000. So the upper bound actually gives the problem size, and the lower bound tells that it's possible this root represents a null tree, right? In other words, we need to think of edge cases. So this is the range of the node value. This is not very essential. So with that said, we're ready to do the coding. I'm not going to go through the problem statement because it's rather straightforward. And also, the idea we want to emphasize is called homomorphism. Homomorphism is a concept from mathematics. So basically, if you have two space, right? Space, let's say A and B, right? And then you do the same thing in the two spaces in a parallel fashion. This is exactly what we mean by homomorphism in plain English. But if you want to understand this concept, it might be some mathematical maturity. So with that said, let's look at the recursion solution first. In order to take into consideration of this one, so this can be a null. So I'm going to use a dictionary. Let's call it, let's see, cloned, right? So I'm going to map null to null. So here in this example or in this coding, it also demonstrates the flexibility of the non-keywords in Python, right? So what I'm going to do is going to write a depth first based traversal function. So basically, it's going to modify this cloned, and then what we want to return is this return DFS root. So here, this is going to return the cloned, the mapped space. So here you can understand A as key space and B as value space, right? So now let's write the logic here. First, if not root, what do we do? So we are going, if not root, we don't need to write this. If root in cloned, right? For example, if root is null, right? So we just need to return cloned root. In other cases, because this if check, root will be not null. So now that root is not null, so what we can do is cloned. So we map the root to new node. So notice the statement of this problem. It's very confusing at the very beginning. So we need to, you will be given the tree in class node, and you should return the cloned tree in class node copy. So node copy is is a copy of the class, right? The class, because the class you can understand as some recipes or scenarios. It's not instance, right? So now, in other words, when we do this, try this new node, you cannot do the node value equals root value. Rather, you need to do node copy. So using a new class name. So with that done, so we can do the same thing. Cloned root. So this is in value space, right? So the value space, we should have this left. So then what you do is dfs and do root left, right? And similarly, cloned root. What's wrong? So here root. So here left, right? Right. It's going to be dfs root right. And then also we have a random pointer. It's random. So that's the root mapped to the value space, then called random. It will be dfs root random, right? And then we just need to return this one. Yeah, this will be the full code actually. So if you are very familiar with this recursion algorithms, you'll be quickly acquired the major idea. Let me first test it. Yeah, it passes the 3 test cases. Now let's submit first. Yeah, it passes all the cases. So I would say this is the one way. Let me make one comment. So let me slightly modify this method. So also to demonstrate to you some Python features, right? Because Python is passed by reference, right, in function. So what we can do is like this. So we can write cloned is set to be default as this, and then we just do this, and then this state will be changed when we call this function, but this is still a valid one. And also you can do this call because by default this will be null to null. So we can do a test. So because we have changed this one to be version v1, so now let's test it. Yeah, it passes all the cases and actually also very fast. So with that done, I guess we are ready to do the iterative format. Let me copy the class and the function signature up to here. All the above, it will change to be version v1. So now I want to write it in iterative format. So this is to understand the details, right? Because sometimes if you write some recursion solutions, you have a feeling that we still do not know the details. So now let's fill that gap in this problem especially. So what we want to do is first to check the edge case, right? If it's null. So if not root, so I'm going to return nothing. So here I need to recover the function name. So this is the one. So now let me make a copy it. So the same thing, playing the same thing as the cloned. And then we first map copied root to be notice that this is node copy, right? The root value. Then we are ready to do traversal. So again, here I'm going to use depth-based traversal. So basically, while s, then what we do, we first get this node is s pop, right? And then we are going to check left subtree, right subtree, or random pointer. So if node left, and then we know this root has a left subtree, then we do the thing using homomorphism, right? So now let's see if node left not in copied yet. So what we want to do, copy it, first map this node left to the value space, so node copy, and the value will be node left value. And then we want to append as node left to the stack. So afterwards, we need to do the holomorphism thing. Holomorphic thing, copied node. So this is in value space. Now we consider the left subtree. It will be copied, say node left. Then actually we do the same thing for node right and node random. So if node right. So here let me move forward fast. So if node right not in copied, right? So we first map this node right to the value space. The node copy node right value, and then we do append. So this is standard for traversal, right? And then we can do holomorphic thing. So copy node right. It will be copied node right. So this is for node right, and then for node random, right? So actually the same thing. If node random not in copied, then copied node random. Map this guy into the node copy of node random value, and then we put this guy into the stack node random, and then do holomorphic thing, that is copied node random equals copied node random. So notice that this line of code is always valid because we have already set this mapped to the value space here, or set the value space, and here we map to the value space. So after this while loop, I guess we are ready to return copied root. So this will be the iterative format. Actually, if you can write this code, it demonstrates that we understand the finer details compared by using recursive format. So now let me first do a test. Let me see if I change this one. Yeah, I changed. So also change back to this way. Node has no attribute random. Let's see where. Oh, there's the random. So here, let's see where's the problem. Let me check the code. If not root, I'm going to return, and we have a copied root and root value. That's right. Have a root, and then we have node pop and node left. If node left not in copied, so here is node left. Here's node left value, and then node left, and then node left. This is also right. And then here, if node right not in copied, and then we map node right to the node right value. This one also right, and then copied node right is copied node right. That's also right. So now let's look at this one. This node is not random, not in. So we copied node random will be node copy node random value, then s append node random, and then copied node. So here, that's the problem. So we need to do the holomorphic thing. So we need to first map it to the value, and then consider the random pointer of the in the value space, right? So now let me test it. Yeah, it passes the 3 cases. Now let's look at the generic case. Yeah, it passes all the cases actually rather fast. So with that said, I guess up to now we finished the coding part. So one iterative format here, and the 2 variants of a recursive format. I guess again I want to emphasize the idea. So here the idea is homomorphism, right? So we do this via the help of a data structure called dictionary or hash map. right? So with that said, I guess that's it. And you are welcome to check out the other several problems in this short playlist, or you can check out other playlists in our channel, and hopefully it will be of help to your practice. Thank you for watching.